Okay, boleh key in attendance sekarang ya. Alright, okay, boleh dengar tak suara saya?
Boleh, sir.
Boleh Okay. So, dah pukul 3, so key in attendance dulu. Okay, so I think we better start now. Okay, Assalamualaikum and a very good evening to everyone. Okay, so for today's session, okay, we're going to learn about Faraday's law, which is the last subtopic for this chapter. Okay, so before we start with the calculation, kita recall balik yesterday. So, let's say kalau saya ada satu electrolytic cell, okay, saya ada satu electrolytic cell, so contohnya saya sini ada uh, copper electrode. Okay, so this one is a copper electrode. Okay, this one also is also a copper electrode, and then saya immersekan both electrode in a aqueous solution of copper to sulfate, in a solution of a copper to sulfate. So kita akan ada wire dan kita akan ada battery. So if you look at the electrolytic cell setup, so this one is going to be the anode, okay, and this one is going to be the cathode. So kalau awak ingat semalam, okay, kita belajar tentang the function of the active electrode itu. The active electrode itu will participate in the redox reaction. So for this case, at the anode, okay, at the anode, the copper electrode itself will release its own electron to form a copper 2 plus ion. Okay, so the electron release will travel. It will travel through the wire, and then that got accepted by the cathode. So at the cathode, so kalau kita ingat semalam, so between copper 2 plus and also water, copper 2 plus have a higher value of standard reduction potential. So compared to water, so the copper 2 plus is the one yang akan discharge at the cathode. So it will gain 2 electron released by the copper electrode to form copper solid. So kalau kita observe cathode itu, kita akan nampak akan ada brown, akan ada brown solid started to deposited on the cathode. So sekarang ni kita boleh determine tau, kita boleh determine berapa je exact mass of the metal yang terhasil through the electrolysis process ni. Kita boleh determine. Cara nak determine dia adalah by referring to the Faraday's law. By referring to the Faraday's law. Okay, so Faraday's law is stated that the Faraday's first law stated that the amount of the substance produced at each electrode, it doesn't matter whether the amount of reactant consumed or the amount of the product formed, okay, is directly proportional to the quantity of charge flowing through the electrolytic cell. So, or we can simplify the Faraday's first law as where M is directly proportional to the Q, where Q ini is the charge. So the charge itu we measure in coulomb ataupun capital C, where M ini adalah mass of the substance. So tak kisahlah mass of the reactant ke ataupun mass of the product. So kita boleh determine berdasarkan the amount of charge yang kita supply to the electron. Tapi the amount of charge itu kita tak boleh determine directly, tapi kita boleh determine dia melalui current. So kita boleh determine dia melalui current. So the formula given is Q is equal to IT. Okay, where Q is the charge. Okay, is the charge where the charge is measured in the unit of coulomb. Okay, I is the current. So current itu kita akan measure dalam unit ampere, mesti dalam unit ampere. And we know that 1 ampere is equal to 1 coulomb per second. Okay, dan time T ini adalah time. Dan time ini awak kena make sure in the unit of second. So from the current, sebab current tu kita boleh measure. Daripada voltage yang kita measure tu, kita boleh measure current. And then daripada current itu kita boleh determine berapa je charge. So daripada amount of charge yang kita kira tu, kita boleh determine how much the reactant consumed in the redox reaction and how much is the product produced during the electrolysis process. Okey, dan kalau kita tahu elektrolisis atau electrochemistry ni, dia chemical reaction yang involved dia adalah redox reaction. So kalau redox reaction bermaksud dia ada involve the transfer of electron. So kita boleh dia ada satu relationship yang kita boleh tengok. So 1 mole of electron, okay, 1 mole of electron is equals to 1 Faraday. 1 Faraday constant ataupun Faraday constant tu kita denote dia sebagai F je lah. So ini kita panggil dia sebagai Faraday constant. So 1 mole of electron is equal to the 1 F atau 1 Faraday constant. Okay, is equal to 96,500 coulomb of charge. So daripada kita punya half equation ataupun daripada kita punya daripada kita punya buat equation redox tu, kita boleh tahu berapa je charge berdasarkan daripada amount of electron tu. Amount of electron, because we know that 1 mole of electron is equal to 1 Faraday and is equal to 96,500 coulomb of charge. Okay, so sekarang kita nak buat calculation. Okay, kita nak tengok macam mana kita boleh apply Faraday's first law of electrochemistry ni dalam calculation untuk determine the amount of product ataupun the amount of reactant consumed during the electrolysis process. Okay, kalau awak tengok dalam notes, kita ada example 9 sampai example 11. Okay, so kita tengok dulu example 9. Okay, kita tengok macam mana kita nak apply kan this relationship. Okay, so example 9, kalau awak tengok, okay, a technician place a faucet with 0.86 gram of chromium metal, okay, by electrolysis of aqueous chromium sulfate, chromium 3 sulfate. So if 12.5 minutes is allowed for the plating, okay, what current is needed? Okay, what current is needed? So maknanya daripada soalan ini kita tahu the mass of chromium form is equal to 0.86 gram. Okay, so time yang diperlukan untuk the plate 0.86 gram of chromium metal tu dekat faucet tu dia mengambil masa 12.5 minutes. So tapi kena ingat, kalau kita nak kira menggunakan formula Q equal to IT, the time must be in second. So that is equals to, kalau awak kira, equal to 750 second. So awak just multiply by 60 je lah. Okay, sekarang ni the equation asks you to calculate the current needed. Okay, so we know that Q is equals to IT. So sekarang ni, T ni kita dah ada. Kita nak cari I. So nak cari I, kita kena tahu dulu berapa charge yang diperlukan untuk menghasilkan 0.86 gram of chromium metal ni. Okay, so kalau daripada kita boleh buat dia punya equation. So we know that the chromium ini adalah chromium 3+. So Cr3+, saya dapat Cr3+ tu daripada formula solution ni, Cr3+, okay, the gain 3 electron, we're going to produce 1 chromium, 1 mole of chromium solid. So kalau awak tengok sini, kita boleh buat tu, kita kena tengok balik relationship yang ini. So 1 mole of electron equal to 1 Faraday equal to 96,500 coulomb of charge. Sebab kan kita nak cari I kan. So nak cari I, nak cari current, kita kena charge dulu. So kita kena determine dulu berapa je charge yang diperlukan untuk menghasilkan 0.86 gram of chromium metal. Okay, so kita buat macam stoichiometry. So 1 mole, okay, sekarang ni kita ada 1 mole of chromium. Untuk menghasilkan 1 mole of chromium solid, kita memerlukan 3 mole of elektron. Okay. So, dan kita kena ingat, dan 3 mole of elektron bersamaan dengan 3 Faraday. Sebab 1 mole elektron bersamaan dengan 1F. So, is equal to 3 times 96,500 coulomb. So, is equal to, kalau awak calculate dengan 289,500 coulomb. Okay, so sekarang ni adakah kromium yang kita hasilkan ni berat 0.86 ni bersamaan dengan 1 mol? So kita kena carilah berapa je mol kromium yang kita hasilkan. So mole of chromium that produced from this electrolysis is equal to 0.86 gram over the molar mass of the chromium. So, kalau kira molar mass of the chromium is 52 gram per mole. So the mole of chromium is 0.0165 mole. Okay. Setakat ini ada apa-apa soalan tak? Setakat ini. Semua okay?
Okay, sir.
Alright. Okay, so kita saling balik. Sekarang kita tahu the mole of chromium yang terhasil daripada proses electrolysis ni is 0.0165 mole. So kalau saya salin balik relationship tu, so tadi 1 mole chromium is equal to 3 mole of electron equal to 3 Faraday is equal to 289,500 coulomb of charge. Okay, so sekarang ni kita ada 0.0165 mole of chromium. So 0.0165 mole of chromium, kalau awak buat cross multiplication, okay, awak akan dapat 0.0495 mole of electron. Okay, dan 0.0495 mole of electron is equal to 0.0495 mole, 0.0495 Faraday. Dan bersamaan kalau awak kira charge dia, guna ratio ni, so hopefully awak tak ada masalah nak guna ratio is equal to 4,776.75 coulomb. So maksud dia, in order to produce 0.86 gram of chromium metal from this electrolysis, awak perlu memerlukan 4,776.75 coulomb of charge. Okay, so kita dah dapat charge, kita bolehlah cari kita punya current. So, we know that Q is equal to IT. So, the current is equal to the charge over the time. The charge is 4,776.75 coulomb and the time tadi kita kira tadi time in second. Time ni mesti dalam second 750 second. So the current itu kalau awak calculate awak dapat 6.37 coulomb per second ataupun 6.37 ampere. Macam itulah cara kita nak apply Faraday's first law of electrochemistry. Okay, setakat ini ada apa-apa soalan?
No.
No, Alright. So let's try another example lah. Okay, yang hari ni saya tunjuk example je supaya awak familiar macam mana kita nak gunakan. Saya akan tunjuk lagi 2 example. So kalau awak tengok dekat note example 10. Okay, example 10. Okay, kejap saya crop kejap. Okay, example 10. By using a current, current of 4.75 ampere How many minutes does it take to plate a sculpture with 1.5 gram of copper from copper sulfate? Solution. Okay, so kalau awak tengok example 10 ni, dia dah bagi, dia nak cari berapa, dia time taken dia. Kita nak cari time taken dia. Okay, so dia dah bagi dah current. So given from the question, the current itu is equal to 4.75 ampere. Now we would need the time. Okay, so mass of copper itu is 1.50 gram. Okay, so sekarang ni kita nak cari how many minutes. So we know that Q is equal to IT. So in order to determine the time, okay, ni current kita dah ada. So kita akan cari dulu kita punya charge. So daripada mana daripada charge tu, kita boleh cari daripada mass. Sebab apa? Sebab kalau refer balik kepada Faraday's first law of electrochemistry, the mass or the substance produced is directly proportional to the charge. Okay. So sekarang ni kita tengok dulu daripada copper to sulfate, dia nak hasilkan copper. So the copper 2 plus ion, okay, dalam copper to sulfate tu perlu gain 2 electron to form copper solid. Okay. So we know that, okay, 1 mole of copper, okay, is proportional to 2 mole of electron. Dan 2 mole of electron is proportional to 2 Faraday. Dan bersamaan dengan, sebab 1 Faraday is equal to 96,500. So kalau 2 Faraday is equal to 193,000 coulomb of charge. Awak darabkan je lah. Okay, so sekarang ni kita nak tahu adakah copper yang terhasil itu 1 mole ke tidak. So kita cari dulu dia punya number of mole. So mole of copper, so kalau awak kira mole of copper itu, awak akan dapat, so 1.50 gram over the molar mass of copper is 63.6 gram per mole. So kalau awak calculate the mole of copper yang awak akan dapat is 0.0236 mole. So bukan 1 mole kan. So kita kena cari berapa je charge yang akan dihasilkan kalau kita ada 0.0236 mole of copper. So kalau saya salin balik kita punya ni. So sekarang ni kita ada 0.0236 mole of copper. So dia bersamaan dengan 0.0472 mole of electron. Okay. Dia bersamaan dengan 0.0472 Faraday. So kalau awak kira charge dia, awak akan dapat 4,554.8 coulomb. So maknanya awak memerlukan charge sebanyak 4,554.8 coulomb to produce 1.50 gram of copper from this electrolysis. Okay, so dah dapat charge tu, kita bolehlah cari dia punya time. Okay, kita boleh cari dia punya time. So because we know that the Q is equal to IT. Okay, tapi kita ingat time yang awak dapat ni adalah time in second. So the time is equal to charge over current. The charge adalah 4,554.8 coulomb and the current tu dia bagi tadi 4.75. So 4.75 coulomb per second. So kalau awak kira, awak akan dapat 958.1 second. But the question want the answer dalam minit kan. So sama dengan awak divided by 60, awak dapat 15.98 minit. So this is your final answer. Okay. Boleh tak ni?
Boleh, sir.
Boleh. Okay, now kita tengok yang last lah. So yang last, dia sama je konsep dia. Awak faham dia punya relationship between number of mole dengan Faraday constant dengan amount of charge itu, awak boleh cari dah. Sebab amount of charge yang kita supply is directly proportional to the mass. So daripada situ awak boleh dah dapat dah. Dia sama je. Okay. So let's write example 11. Okay, ni example yang sama dalam notes So let's write example 11. Okay. So to protect it from corrosion, a section of iron pipe is electrogalvanized with zinc. Okay, from a basic solution of this compound. Okay, so dia dah bagi dah equation. Okay, if the process take 8.75 minutes with a current of 7.03 ampere, what mass of zinc is deposited? So kalau kita tengok balik, the Faraday's first law, dia kata the mass produced is directly proportional to the charge. So kita kena cari dulu charge. So nak cari charge, okay, nak cari kita punya charge, so we know that the charge is equal to current multiply by time. So current dah ada, so current dia dah bagi, time pun dia dah bagi, so kita boleh tahu dia punya charge. So is equal to current is 7.03 ampere. The time itu, ingat, the time itu mesti dalam second. So awak kena multiply by 60. So 525 second. So charge awak dapat dah 3690.75 coulomb. Okay, so sekarang kita nak cari what mass of zinc deposited kalau kita ada 3690.75 coulomb of charge. Okay, kita tengok balik relationship tu. So we know that kalau ikut kita punya equation ni, 1 mole of zinc dia datang apabila kita ada 2 mole elektron. So sekarang ini kita boleh buat, so 1 mole of zinc is proportional to 2 mole of electron. So 2 mole of electron proportional to 2 Faraday bersamaan dengan 2 times 96,500 coulomb bersamaan dengan 193,000 coulomb of charge. Okay, sekarang ni charge ni kita ada 3690.75 coulomb. So kita buat terbalik pula. So 3690.75 coulomb is equal to, kalau awak kira awak dapat 0.038 Faraday. So 0.038 Faraday is equal to 0.038 mole of electron. Okay, so 0.038 mole of electron kalau awak kira bersamaan dengan 0.019 mole zinc. Macam mana saya dapat value-value ni? Saya guna ratio je. Dia sama yang macam stoichiometry tu. Dia sama je. So sekarang ni kita dah dapat dah. Mole of zinc. So dah dapat mole of zinc, kita boleh dah cari mass dia. So the mass of zinc deposited itu, so the mass of zinc deposited tu is equal to 0.019 mole multiplied by the molar mass. So the molar mass of zinc is 65.4 gram per mole. So we can cancel out per mole and mole. So awak dapat 1.24 gram of zinc. Okay, itu sahaja. Okay, ada apa-apa soalan?